Most substances increase in volume when heated. The increase in volume when a substance is heated is called thermal expansion. Temperature. When water is heated, it becomes warm or hot depending on how long it is heated. On cooling, it becomes cold. In what way then do hot water, warm water, and cold water differ? Hot, warm, and cold samples of water differ in terms of temperature. Temperature is the degree of hotness or coldness of a substance. It is measured in kelvins, K. It is measured using an instrument called a thermometer. Ordinary thermometer. The diagram below shows the main parts of an ordinary liquid in glass thermometer, the type commonly used in the school laboratory. Ordinary thermometer consists of mercury held in a glass tube with a narrow bore or hole. Mercury expands when temperature rises and contracts when temperature falls. This makes the level of mercury thread to move up or down the narrow bore so temperature can be read directly from the scale. Clinical thermometer is another type of liquid in glass thermometer. It also uses mercury as the thermometric liquid, but its use is limited to measuring body temperatures of patients. For this reason, it has a short temperature range, usually 35 to 42 degrees Celsius. It also has a large mercury bulb, a feature that makes it sensitive to changes in body temperature. Using a thermometer. In the video clip presented, observe how a thermometer is used. The animation below shows how an ordinary thermometer can be used to measure the temperature of water. What is the boiling point of water? Suggest a place where this experiment was probably carried out. Note carefully that the thermometer should not touch the bottom of the beaker. Maximum and minimum thermometer. This thermometer indicates both maximum and minimum temperatures reached in the course of the day. Expansion of solids, liquids, and gases. What happens to a substance when it is heated? There are many possible answers to this question. However, one of the possible effects of heating a substance is expansion. In this section, we learn about the expansion of solids, liquids, and gases. Expansion of solids. Bimetallic strip. The animation on the next page demonstrates the expansion of a bimetal strip consisting of metals X and Y. Click on the play button and observe what happens when the bimetallic strip is heated. In the following demonstration, a bimetallic strip is heated directly on a flame. Click on the play button and observe the effect of hitting the bimetallic strip. Which of the metals X and Y expands faster? The bimetallic strip is observed to bend towards Y. This shows that X expands faster than Y. Expansion of liquids. The following activity demonstrates expansion in liquids. Click on the play button and observe what happens. When the flask is heated, the level of water drops slightly, then rises steadily. This is because the glass container initially expands faster than water, but after some time, water expands faster. On cooling, the level of water rises sharply, then drops steadily. Why is this? Expansion of gases. The following animation demonstrates the effect of heating a gas. In the setup, air is trapped in the flask with a liquid index acting as the cover. Take observations and explain the behavior observed. When air is heated, the liquid index moves steadily outwards. This shows that the air expands to occupy a larger space. All gases expand when heated. Applications of expansion and contraction. Expansion and contraction have desirable and destructive effects. The following are examples of precautions usually taken to avoid or minimize the damaging effects. Steel bridges. Some bridges are supported on rollers to enable them move freely as they expand or contract. In other designs, expansion gaps are provided to absorb the increase in length during hot seasons. Railway lines. Expansion gaps are provided between rails. Without these gaps, bending easily occurs during expansion, and this has been a major cause of train accidents in the past. The modern ways of preventing bending of rails due to expansion, however, involve overlapping and welding of rails. Steam pipe. A steam pipe is looped at some points along its length to allow for expansion and contraction. This prevents the pipe from bursting due to expansion. Observe the expansion gaps in the photograph given below. Meaning of anomalous expansion of water. When water is cooled from 4 to 0 degrees Celsius, its volume increases. However, other substances decrease in volume when cooled. Water therefore shows an unusual behavior. This unusual behavior of water is also called anomalous expansion. The graph below shows how volume varies with temperature in the anomalous behavior of water. Effects of anomalous expansion of water. Icebergs. Due to anomalous expansion, water is least dense at 0 degrees Celsius, the temperature at which ice forms. This partly explains why ice is less dense than water, which is above the freezing temperature, so it floats on water. In cold regions, therefore, large masses of ice called icebergs float in the sea and are a serious hazard to sea transport. Frozen lake. In cold climates, temperatures sometimes fall below 4 degrees Celsius. Due to anomalous expansion, cold water in rivers and lakes is expanded and less dense, so it floats at the top. As the temperature falls further, ice forms at the top, thereby insulating the water underneath. This prevents the rest of the water mass from freezing. The liquid water below the ice continues to support the life of fish and other living things found in the sea. The following animation illustrates the process by which a lake freezes. Observe the movement of particles, leading to formation of ice at the surface. Study the photograph of the frozen lake.